Next problem. In 5 iteration, find the solution to the system of linear equations by Jacobi's method. So we will use the same linear equation as yung Gauss-Seidel sample problem. So Jacobi's iteration method is an alternative to Gauss-Seidel. Rather than using the newest or the latest available known value of the unknown variable, Jacobi's method uses a set of new x's or new known variables on the basis of a set of the old unknown variables. Okay, so I will illustrate that one later. New values are generated for each iteration. They are not immediately used in the next solution to the variable, but rather they are retained for the next iteration. Okay, so the approach is similar with Gauss-Seidel, except that the new values of the unknown variable are not used. So same pa rin, we have to check the dominance of the diagonal elements, and since we are using the same set of system of linear equations, so we are sure that the convergence criteria is guaranteed. So tabular pa rin ang solution natin, and we will express the unknown variables in terms of the other. Initially, we will set u, v, w, and x as equal to 0. So ito yung first set of values natin. Okay, so that u, v, w, and x is equal to 0. For the first iteration, let's solve for u using v, w, and x is equal to 0. So we find u is equal to 1.75, and then v is equal to negative 2.8, w is equal to 2.667, and x is equal to 3.75. So ito yung sinasabi ko kanina na we did not use the latest available value of the unknown variable. For example, for solving for v, we know that v is dependent in u, okay, but we did not use the latest available value of u, so that ang ginamit pa rin natin is u is equal to 0. Okay, so ang negative 14 over 5 is equal to negative 2.8. Next, sa w, w is dependent sa u. Okay, so we also did not use the new value of u to solve for w. Instead, we just set it to be equal to 0. So that w is equal to 16 over 6 or 2.667. Same goes with x. So we did not use the new value of u and v. Okay, ang value ng u and v is still equal to 0. Okay, so in the next iteration, we will now use this new set of values for u, v, and w, and x to solve for the new values of u, v, w, and x. Okay, so that we find that the new values are negative 0.283 for u, and then for v, that's equal to negative 2.933. For w, that's equal to 3.958, and for x, that's equal to 2.788. So itong negative 0.283, nakuha natin yan when we set v is equal to negative 2.8 and w is equal to 2.667. Okay? And then yung v naman, nakuha natin yan if we set u is equal to 1.75, w is equal to 2.667, and x is equal to 3.75. And then for w, we also obtained that from this equation, but u is equal to 1.75, x is equal to 3.75, and same goes with x. We get the value 2.788 when we set the value of u equal to 1.75 and v equal to negative 2.8. So hindi natin ginagamit kaagad yung latest available value of the unknown variables. And if we continue the iteration process, we find that in 5 iterations, we were able to arrive at this solution. So the approximate value of u, v, w, and x are equal to negative 1.046, negative 3, 4.034, and 1.984 respectively. The true value is -1, -3, 4, and 2, giving us a relative error of 4.6%, 0%, 0.85%, 0.8% for U, V, W, and X respectively. So as you can see, we were able to have a 0% error for the value of V because in just 5 iterations, nakuha na natin yung true value ng V. But other than that, the other variables, namely V, W, and X, have less than 0% na error except for U na medyo malaki yung kanyang error. But this is an iterative method, this is an approximation, so error is absolutely normal. Okay? So I think that's it. So for me mas hindi nakakalito yung Jacobi's method compared sa Gauss-Seidel's method. Kasi yung Gauss-Seidel, you have to immediately use the latest available value of a certain unknown variable para makompute mo yung next unknown variable. So ganun lang naman ang difference ng dalawa. But it's up to you kung ano yung mas comfortable kayo. You may use Gauss-Seidel or Jacobi's method in solving for the system of linear equation by iteration. I think that's it. Thank you very much.